So this is designed to be for total beginners. So this is just like 2 minutes on how the internet works. The internet works basically. The internet is like a series of computers, which I think we all know intuitively, but I'm hoping to kind of spell it out a little more explicitly. So like there's your computer, which is called the client. So when I say your computer, that can be I'm going to write Eliza's computer, even though that's not your full name. So we have different clients, right? And the metaphor is for a restaurant. So you go into a restaurant and there's a bunch of clients. That means basically people who are eating food at the restaurant or actually receiving food at the restaurant. And then who is the person who serves the food? What's that? What do you call that? The person who serves. Waiter, yeah.
The server, the waiter.
The server. That's what I'm going for. So the server. So I'm sure you guys have heard this in like a computer science context before. So basically, your computer, it's literally, the internet is about connecting computers. Again, this seems basic and obvious, but I think for most of us actually thinking through it is like a new experience where your computer is called the client. When you go to a website, for example, just the example because we're all here right now, passionclass.co, when you go to this website, your computer is the client. That means it's asking the server to get stuff. And the server loads the pages and serves the pages. It serves information. So the metaphor of a restaurant works perfectly. The only difference is that instead of the difference is that instead of getting food, your machine is getting information. Okay, I think that's clear.
But where's the kitchen then? It's immaterial. It's not physical. The kitchen of the internet.
Well, right, exactly. So there's no kitchen, right? Yeah, it is. It's client and server. Well, actually, let's expand that metaphor. Even though the reason it's called a client and a server is the same reason they're called clients and servers or waiters at restaurants, because they literally serve information to people who are like, please send me information. The kitchen, I don't have that. But what I do have for you, instead of a kitchen, is I can show you a database. So a database, does anybody know or based on the name want to guess what a database does?
Is it where all the information is stored?
Exactly. Very good. Very, very good. Anything else? So that's 80% of it right there.
Is the database also where everyone kind of like has those things?
Yeah, absolutely.
Like a library, maybe?
That's a good analogy, actually. That's a very good analogy. The database is basically the place where your information gets stored. So the server stores all of its information in a particular database or multiple databases. That's not super crucial. Like for now, we're just going to pretend there's always one database for one server. So for Passion Class, for example, you literally are on a client. Okay, your client is your laptop, it's your phone, it's your iPad, whatever it is, and then it sends a request actually to a particular computer that is the server for Passion Class. So you actually have two different computers there. And actually there is like this little tiny process that I'm just going to mention, and then we don't ever have to worry about it again. It's actually when you go to, for example, if you go to passion-class.com, which is where we are right now, that actually gets translated through a service, which is basically another computer. Your computer sends a request to this service and says, tell me what the IP address, aka the address is. It's like looking it up in a phone book for Passion Class, and then your computer gets back a numeric, like a number, 192.168. Blah blah blah. it gets back a number for passion class, and then your computer then knows the address of passion class and talks directly with that service. So that's not super important, but that's just like there is this like little service that first translates the name, like the fun name we have, passion class, to like a number that the computers use to identify its address. So anyways, and then the backend server connects to a database and says, it basically reads and writes all the information there. So passion class, like my database it doesn't have a ton of information. Like, if you sign up for the emails or ask for a discount code or something like that, your email gets stored in a database, for example. But like, let's go to the example of Instagram. Like if you have your Instagram account, every single piece of information that you have on Instagram is all stored in databases. Alika writes a comment on Dominique's wall. That's Facebook. I don't know. I'm not an Instagram guy. Sorry. But if she like writes a comment on her story, then that'll get stored in a database. And then how that basically works is Alika's client sends a request to the server, the Instagram server, which is literally in like a warehouse, probably in like, depending on where you are, like maybe California, maybe Ohio, maybe New York, whatever, maybe London, depending on where you are. And then there's going to be a server that writes information to the database. Alika wrote on Dominique's story. The server writes that to the database. Then I go and look at Dominique's story. And so then my client sends a request to the server, hey, send me the information. I want to see the information about Dominique's story. And then the server, the Instagram server, the Instagram's computer will then reach into his database, say, give me the information about Alika's story, process that information, and send it back to the client. So that's about it. All I want to do here. Like that's a very simplified structure. Obviously, Instagram, if you think about it, they have like 10 million people on there at any time. Like I'm probably not even exaggerating with that. And so clearly the backend is not one server on Instagram because one computer can't handle 10 million clients at the same time. Like regardless how good of a server it is, one server can't handle 10 million clients at the same time, just like in a restaurant. And so there's multiple servers who are connected in a way that's like too complex for our purposes. But that's basically kind of what I wanted to share. Oh, but the other thing I wanted to share is the reason the server is very important is because you can't talk to the client. The client can't talk to the database directly. Does anyone want to take a guess on why that is?
Isn't it because the information's already in there, and it's like a manual. The manual's there, so you can't. It's on PDF, so you can't touch it. So it's just,
exactly. Now you're getting very close. You're getting very, very close. I'm sorry?
Like an example, like you get in a car, like you're going to go somewhere, so the instructions are there, and you have to follow the instructions. If you don't follow the instructions, you get lost.
Exactly. And you can't just give anybody the key. And that's the difference. The information's there, and you don't want to just give anybody the key. Because, so for example, if I had direct access to the database, in theory, so basically what I can do is I can tell the server, hey, Joe, I authenticate. I have to log in on the machine, on my local machine, blah, blah, blah. That's too far, how that actually works is beyond our purposes for today. But so I get logged in, and then my client is identified as Joe's Facebook, or John's client is identified as John's Facebook, or Anna's client is identified as Anna's Facebook. If we had direct access to the database, then John could say, hey, John could just say, like, write a post from Anna to Alika that says blah, blah, blah. But with the server actually has the ability to act as an intermediary and kind of check, okay, do I actually want to write this information to the database? Like, do I actually trust what the client's saying? Do I like what they said? Do I trust it? So that's the importance of the server. And the other way around. So that's about writing information. On the same side, on reading information, if I have an account, if I have my Instagram, if I had direct access to the database, then I'd be able to see all of Anna's posts, and I'd be able to see all of John's posts, and I'd be able to see all of Dominique's posts and all of Eliza's posts and blah, blah, blah. But what the server does is it says, I say, hey, I'm Joe. And the server says, I will only serve you I have access to all the information in the database, but I'm only going to serve you the information that you should have access to. So that's why you need this like 3-part architecture where you have the client, and then you have the server, and then you have the database, because the server has access to the database. And then the server kind of like filters so that the client can only get access to the parts of the database that they should have access to. Okay, that was actually... Oh, sorry, I heard a question.
Sorry, I have a question. Is it similar to, for example, if a specific language is used to, for example, I don't know, in a video or in a picture that you want to post, and then, for example, Instagram says, oh, you're using this language, so you can't post it. Is that like the intermediate of like, does that make sense? Is that the mediator of, is that the server basically?
What do you mean language? You mean like English, Spanish, or you mean like computer language?
No, as in if there's a specific word that you're not allowed to use on social media, or if it's like offensive or whatever.
I see. Absolutely,
like...
that's the job of the server. I understand now. Yes,
okay.
That is absolutely. So yes, if I were to write, so on this server, I'm sure Instagram has a bunch of programs that run on their servers that they may, I don't know exactly how it works on Instagram, but yeah, I'm guessing that when you actually make a post, I don't know if they do it right at the time that you make a post, or if they like have another server over here that, it's not really a server then. It could be, but they have actually another, what I would call it, in this case, I would call it a service, that it like checks those posts to make sure that they are okay. I don't know exactly where it happens, but it's definitely the server side. Absolutely. It's not happening on your machine, and it's not happening in the database itself. It's happening somewhere on Facebook's computers. Absolutely. I am going to switch us over to doing some actual coding. So those who can and are willing and brave enough to do so, I would love for you to open your web browsers at the link I sent in the chat, which was, again, it is onecompiler.com. Let me know if it doesn't load for anybody for some reason. If there's like a drop-down box, I would select JavaScript. We wanted to say JavaScript. So if it might say Python, it might say something else. I mean, it doesn't really matter what it says, but I'm doing JavaScript here. So this is almost always the first program that anybody writes. I don't remember if I wrote this or if it came pre like this, but it should say console.log hello world. So let's all write that if it's not already there. And then we'll run our JavaScript. Oops.
Console in black, log in green, and then hello world in red.
That's not actually part of the code, but yes, it changes the colors for you so you can, as you get into it, it helps you notice what kind of data type that is. Like, that's beyond our purposes now. But what the actual letters and numbers are, that is important, and it should end with a semicolon in theory. So does everybody have that? Do you want to explain what you think that this program did when you clicked run?
If I click run, it come out output hello world.
Very good. Exactly. So what is happening here?
Now I'm ready to start using.
That's true. That's true. That's 100% correct. Elizabeth, you wanna take a
pose to push that button?
Feel free to press run and watch this area when you do. Any other thoughts? Anybody else want to chime in and explain what they think is happening? It's really not. I can just explain.
I think it's starting a conversation
That's well. We are. Whoa, this is your first lesson. We are not that. We are. We are not there yet.
Oh, okay.
So that would be. So what you're suggesting is prompt engineering. So prompt engineering essentially is this. You probably heard of it already. In and this is going to be the way a lot of software is written in about probably 2 years already. That it's actually, right now you still do have teams of programmers like working to code up things. However, in a couple of years, that's going to change pretty fast. That basically you're going to see situations in which like prompt engineering is basically where you start a conversation with an AI model and your AI model like outputs the code and you don't even really see it, and then it just builds the whole program for you. We're already on that path now. Like I've seen some prompt engineering be pretty impressive. We're not there yet, but in 2 years we will be. So, but no, this is truly the basics of coding. So what this does, this is called a function. You know it's a function because it has two parentheses. So that's basically what a function means. It has an open parenthesis and a closed parenthesis. And we're calling the function. When you calling the function, console.log just renders the text in your output that you put in there. Okay, so that's all that does. So what this function does, we have a program right here. This is a program called index.js. I could also save this program into a document or like into a program on my computer, and then I could call that program, and then a little window would pop up on my computer that just says hello world. So that's what this is. I'm going to also just take a second and show you like practically where this is valuable. So again, I'm going to go to Passion Class because that's the website I have the most experience with. So on any website, you can right-hand click and click Inspect. Inspect opens what's called the inspector. You get all this information about websites, which we will talk about another time. If you do my HTML class, you will see all of this with me. Not all of this, but you'll see some of this. Here we have the console, okay? The console, oh, look at this. The console is all this information about, the console is all this information that developers can put here to kind of, they can write things to themselves, for example. Some of this stuff I probably should have cleared before sending it to production. As I mentioned, I do this alone, so little stuff like that, whatever, it doesn't really matter. But this is like in the browser. The browser is the Safari, Firefox, Chrome, whatever, where you browse the internet with. In the browser, this is the browser console. If you have a backend program where you have a program running on your machine outside of a browser, it's that like black terminal window that I'm sure you've seen before. So that's what the console is, okay? But a lot of programs, like if I was just making a tic-tac-toe program where I could like play with a friend and have it like log, it would probably render a board, like a little board right here. It could render a tic-tac-toe board here. So it could look something, I will actually just draw one out. Oops. Let's just say like X, 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 O.
In coding, do you have to sort of memorize codes?
Well, so what does memorize mean? Short answer, yes. It's similar to a language. We would literally call them computer languages, right? Yeah, and so it's kind of like you do need to know basic words, in order to communicate with the computer. So what the computer language does is it makes it understandable to your machine. And so yes, you do have to know commands. There are certain commands you just have to know. Absolutely. They're not so many. I mean, it is kind of like, it goes quick. I promise it goes quick. Like of course it's like any skill where you feel like, oh my God, it's taking forever, which in a certain sense it does. But in another sense you do learn quick. Like it goes quick. So
that makes sense, yeah.
Okay, so this is just an example output of this is what I could print. If I was making a tic-tac-toe game, I might have it print something like this. So this \n means line break. So that would be an option of how to print a tic-tac-toe board, for example. Okay, so let's move on to something a little more complex.
Question. Just to repeat, recap. So the function is those two parentheses, and they're like the paper, and the pen is basically you're typing on the computer, but you're actually moving the pen, and whatever you're writing with the pen, it's basically going to show up on the side where the output word is. Yes.
So in this particular example, that works pretty well, but that wouldn't be true for all functions. So let me take a step back here. So a function.
Because we're just going for the simple. So in layman terms, because we're all beginners, that's kind of why.
Right. So a function is something that is a hunk of code that you can call a couple of times. So for example, log something, this, and then let me do hello John, and let me do hello Eliza. It says Eliza. I know that's not quite right. Okay, so what is going on here? So what you're seeing now is you are declaring squiggly brackets are an indicator. Something opens, something closes. Okay, so we have a function. A function is a hunk of code that is reusable. Okay, a function essentially is a hunk of code that is reusable. So we've named this function log something, and it takes one. This is called a parameter or an argument. It takes one parameter which we've called log me. Okay. This is this is probably too hard already. Hold on one second. I will come back to the function thing in a minute. Let's actually take a step back. Let me ignore your question for now and take a step back. Okay. So let's start with a variable and say, Elizabeth, what's your favorite number?
I don't have one, but I would say 3. That's popping in my head.
3 sounds good. And then John, what is your favorite number?
5.
Okay. Okay, so what we've now done, this first line of code does is it reserves a place in computer memory and says, let's call this space Eliza's favorite number and save that as number 3. Okay, so we now have a space in computer memory called Eliza's favorite number, and in that space, there's the value of 3. Same thing here. Now we've reserved a second space in computer memory. We've named that memory, that space, John's favorite number, and we've assigned it the number 5. Okay, so what I can do here is I can say, you have question? No? Okay.
For function, the keyboard in the computer also have a function buttons. Is 9 of them, different function. So it's the same principle of function, isn't it? No, I don't know.
Same principle as what? So hold on, let me come back to the functions. Let's come back to the functions because that actually is a step. So let's start with variables. So this is a variable. So a variable is essentially something that we save in computer memory. Is something that we save in computer memory, okay? And that's what a variable essentially is. So it's not that dissimilar from a variable in algebra. It's not exactly the same, because if you remember algebra, like we'll say 3 plus 5 equals x. What is x? Like, what is the variable x? The variable x is 8, right? 3 plus 5 is x, so x is 8. That's algebra 1. And so here, like a variable is like anything but it's kind of like, this is more like saying like because I'm saying the first letter of this. E plus j equals x. E equals 3, j equals 5, so e plus j is 8. Okay, so 3 plus 5 is 8, e plus j is x, e equals 3, j equals 5, so e plus j is 8. So it's very similar to a variable in algebra. I mean, I don't know if that was helpful or confusing, but my point here is what a variable is in its simplest form is you reserve a space in computer memory and save something to it, and that's what a variable is. Okay, and then you can do calculations here. So then we say, okay, we know Eliza's favorite number is 3 and John's favorite number is 5. And if we say, get me the sum of Eliza's favorite number plus John's, or like, give me the sum of Eliza's favorite number and John's favorite number, and console.log it so it appears in the output, then we get 8. If I don't console.log it, I can still sum it, but it just gets lost in memory. Like it says program did not output anything. So that's what this does. So that's like a computation, okay? That's an easy computation, but let's say we said, but if we made this Eliza's favorite number and this John's favorite number, the computer can sum that a lot faster than we can. So that's one example.
Question. So, you have to, whatever you want to put into the, let me see. Okay. You have a blank board and you want to, like you said, put 3 plus 5. You would have to put, instead of putting in numbers, you put it in words, but you put it close together, right? No spaces. And if you put run, it would show you that in number form, right?
I didn't understand. I'm sorry.
If you wanted to calculate something, or if you wanted to say something like you did on the example, everything would have to be close together, right? No spaces.
You're saying, I see, Eliza's favorite number. Got it.
Yes.
Yes, that is true. Yes.
So with the let, why did you put let?
Very good question. Very good question. So in JavaScript, there's actually 3 types of variables. There's var, let, and const. I'll write that here. So also if you start a line, or actually anything that you write after double slash is called a comment. That means that when processing your code, the computer just skips over it. So you can read it, but the computer doesn't read it. So that's what the double slash means. So there's 3 types. There's var, let, and const, 3 types of variables. Var is something that in my professional career as a software engineer in JavaScript I've been doing JavaScript for a long time now, 6-7 years, more than that. I don't think I've ever used it, ever. If I did, it's been a handful of times, like once. So var, I'm just going to forget it, okay? So how you can think of this is let and const. Const means it's a constant. It means we're not going to want to change it. So const, so these would probably be very good for const. These would be good const, actually. That means we're not going to continue to change them. But let me give you an example. What I could say is now we're moving on to if statements. I wasn't even going to necessarily do it in this order, but that's fine. So let means they're variable, okay? So that means you can change the number. If I say if Eliza is very competitive, or Elizabeth is very competitive, and if Elizabeth's favorite number is less than John's favorite number, then Elizabeth's favorite number becomes John's favorite number plus 1. Okay, so the reason the reason a let is important is it says this number can change. In my code, the value. So like I said, we save a space and we declare a space in memory, and refer to it going forward as Eliza's favorite number, Elizabeth's favorite number, and we have another space in memory called John's favorite number. And we refer to it via that name, okay? What we do is at the moment of declaration, the moment of saying this space in memory refers to this, we say it can change in the future or it can't change in the future. There are advantages and disadvantages to that. It's a little beyond you need more of a feel for like why you would declare something as a const. There's plenty of cases it's very commonly used. It's not really that important for our purposes. So you could have it either be let or const at this point. You might get an error saying you've declared something as a constant that doesn't need to be or can't be declared as a constant because you update it later. So, but that's all that let does. So let tells your computer, I'm going to be creating a variable. This is its name. This equal sign is called the assignment operator. That means whatever's on the right side of the assignment operator gets assigned to the space and memory on the left. And the reason there's no let here, does anybody know or have a guess why there's no let on line 5 when I say Eliza's favorite number is now equal to John's favorite number plus 1?
Because the space has already been reserved at the top where the let is.
Very good, Elizabeth. You are a natural. Excellent. When we declared this space, what we did on line 1 is declare the space in memory. The space, exactly like Elizabeth said in beautiful terms, is the space was already declared in memory or reserved in memory. Actually, that's an even better word that you used. And so what we're doing here is we're actually reassigning. So here we're doing an initialization. We're doing a first assignment. Here we're reassigning it. We're saying, okay, it's no longer 3. Elizabeth's favorite number is no longer 3. It's actually John's favorite number plus 1. So it's actually 6. So that's what we're doing here.
Comment. So let is like you can make something permanent, but you can change it as you go along. And then the constant is basically it's going to stay the same no matter what.
Exactly. Your code will break if you try and update it. It will just fail.
So the content, well, for example, like the content is like the alphabet. It never changes. It's 36 letters. You can make 1,000 words and the alphabet will never change. Let would be like
it's a good thought, but it's a good thought. That's a good thought, but that's nope. So in this case, it would be more like something like Elizabeth says, my favorite, like John. Actually, in this case, it's really with John. I would actually, if this was our final program, this is exactly how I would write it. I would say Elizabeth's favorite number is 3. She might change her mind. There's a possibility that she'll change her mind. John's favorite number is 5. It will never change if John says it. In this case, it doesn't quite make sense, but like let's say like a better example is I say if I'm designing a house, I'm not even going to write code for this. If I'm designing a house, maybe I have window count as like 7. Okay, the number of windows in that house can realistically never change. Okay, like maybe it can in the real world, but for the purposes of what our program can do as we model a house, the number of windows can't change. But door is open, front door is open, can change. It's open now, it closes later. It opens now, it closes later. So that's what it's more like. It's more like anything that is not going to change in the course of our program, we should declare as a const. But again, what that is, we don't need to worry about at this point. It's you gain an intuition for that with time, and it's not so complicated. And if you did everything as lets at the beginning, that'd be totally fine. So now we have variables down. I think this is So now we have variables down. One other type of variable I want to show you actually is a string. So we've now seen numbers, and the other type of variable I'm going to show you right now is a string. So let's say I have well, we already saw a string actually. So remember that hello world where we said console.log hello world? So like that was already a string. So anything in these quotes that actually show up as red on this in this development environment, in this program, if we write them, this won't really work. Yeah. So let me actually just comment this out that means that code won't run, right? Because commenting out is code that doesn't get processed by the compiler. It doesn't get processed when we run it. So we can read it, but the computer doesn't ever read it.
So the question, the symbol for constant without writing that word is the slashes, the dashes.
Comment, exactly. The double slash at the beginning of the line. Sorry, I misheard what you said. I thought you said const, and I meant comment. So we call these.
Sorry.
No. That's fine. I misheard, or maybe yeah. But the comment is something that a comment is like it's a comment for us to read, but not for the computer. And yes, it's the double slashes exactly. So this line of code now, it still says Eliza's favorite number is 3 and John's favorite number is 5. But now when we run Eliza's favorite number plus John's favorite number, does anybody want to guess what this is going to do? What is the output? Here in output last time, we said when it was 3 and this was 5, when it's 3 like this and 5 like this, we press run and our output is 8, right? Because it says console.log, which sends something to output. Eliza's favorite number plus John's favorite number, 3 plus 5 is 8. Okay, now I'm changing it so this is 3 is a string, and this is 5 is a string. A string is basically a word for text, and you can probably see the difference by, the fact that it's written as text. What do you think will be the output if I click run now?
It's gonna show as like 11, but
That's a good
8,
thought. That's a very
8 in letters. No?
That is a good thought. Who said that?
Elika.
Okay, that is a cool thought, Alika. That is a good thought. Let me change it to this. What do you think? So what do you think will happen now? So Eliza's favorite word is 3. John's favorite word is happy. What is going to happen if I say console.log Eliza's favorite word plus Eliza's favorite word plus John's favorite word?
3 happy.
That's exactly right. So we'll get 3 happy here. So it's if I have this string plus this string, what the word for that is in computer science is called concatenation. So here it concatenates 3 and happy. So that's what that does here. And if I had done 3 and 5, then we'll almost get 35, but we get 3, 5. So that's how that'll happen. But that was a cool thought. I'm actually like, because the other thing is that's how ChatGPT would think about it. But this is not ChatGPT. This is like us having to think like a computer. Like the computer's like 3. This is a piece of text. 5. This is a piece of text. Piece of text plus piece of text is different piece of text. Like that's.
But I think I didn't look at the plus.
No. I totally see what you were saying. Like I think it was a good. Yeah. It was a good thought. It was a cool thought. But I'm just saying this is how the computer works. So that's it's just how it works. Okay. So now we've seen. Perfect. So now we've seen strings. Well, we've seen a couple things. So we started at how the internet works. We saw the front end, which is the client. We saw the back end, which is the server. And we saw a database, which is where information is stored. Then we transitioned. We saw how things are logged in the browser. The browser being what you browse the internet with. Chrome, Firefox, Safari, etc. We logged hello world. We logged our first string. We've declared variables of both types, numbers and string. Again, a string basically means text. So this is a string. We have seen lets and const, so variables that can change and variables that can't change, that are constant. And we have even seen, we've done summation, and we even saw a few minutes ago our first if statement, which I'm actually gonna put it back in here just so we can take a look at it again. So if you wanna type an if statement in your own, feel free. Feel absolutely free to do that. So that, and then you can see an if statement. Let's just read this together one time. If Eliza's favorite number is less than John's favorite number, then Eliza's favorite number is equal to, or becomes, essentially, this is called the assignment operator. So as Elizabeth said, we reassign the space in memory. We delete whatever was at Eliza's favorite number and assign a new value to that space in memory, which is John's favorite number plus 1. So the computer looks in the space in memory that's John's favorite number and finds 5, and then it adds 1 to that. And then Eliza's favorite number is now whatever John's favorite number, it computes this side. John's favorite number is 5 plus 1, so that's 6. Assign that to Eliza's favorite number. Okay, Eliza's favorite number is now 6. That's how that works. So this is how the if statement works. I'll make just 2 super quick comments on it. One, that what is within the parentheses is what we call the condition. So in the if statement, if Eliza's favorite number is less than John's favorite number, that's the condition. So if this is true, then we do what's in the squiggly brackets. Okay? If this is not true, so now I've made this greater, if Eliza's favorite number is greater than John's favorite number, which it's not in this case because 3 is not greater than 5. So Eliza's favorite number is 3, John's favorite number is 5. So if Eliza's favorite number is greater than John's favorite number, which it's not, then do this. But we don't care what this is, right? We don't care what this is. So that's the important thing to note there, that we do, this is the condition. The condition is what's within the parentheses here. If, do whatever's in the parentheses, then do whatever in the squiggly brackets. But if it's not true, then nothing will change. So I'm going to press run right now. What are we going to get when I press run? Well, so let's run through it line by line. So Alika, what happens on line 1?
I can see Eliza's favorite number.
Mm-hmm.
And then, but it can change, and John's favorite number isn't going to change. It stays as 5.
Okay, and what is Eliza's favorite number initially?
3.
Uh-huh, very good. Okay, so then on line 4, what happens on line 4?
On line 4, Eliza's favorite number is John's favorite number plus 1, so 6.
No, sorry, not line 5, line 4, line 4.
Oh, sorry. Oh, Eliza's favorite number is higher than John's favorite number.
Right. Is this going to return true or false? Is Eliza's favorite number higher than, greater than John's favorite number? Or is this true or false?
Because it could change.
Right. It could change, but right now, when the computer checks it, it's gonna check for right now. It's not checking for a possibility. It's checking what it is right now.
Oh, okay. Well, then it's false.
So then it's false. So when it's false, I didn't do a wonderful job explaining this yet, but when it's false, do you think we go in these squiggly brackets? I haven't explained that great yet. So the answer is no, right? So let me make sure I'm clear on this. So the point of the if statement, sorry, it's one of these things where like I just write it and I'm like, yeah, I've seen this a million times. I know exactly what this is. But like it's, I understand. Like so the point of the if statement is it gives us logic that is conditional, okay? It's called conditional logic. It's on a condition. So if this condition between the parentheses is true, then we follow the logic within the squiggly brackets. If the condition within the parentheses is true, then we follow the logic in the squiggly brackets. However, if it is not true, then we do not follow the logic in the squiggly brackets. Okay? So is the condition in the parentheses true, Alika?
No, it's not. So
Okay.
we don't follow with the 5th line.
Very good. Exactly. So when we get to line 7, which is, I know it's a blank line, But when we arrive at line 7, what is Eliza's favorite number in our computer memory right now?
It's 3.
3, exactly right. It started as 3 and it never changed. We declared it as 3, or we initialized it as 3, and we and it never changed. What is John's favorite number?
It's 5.
It's 5, exactly right. Because we initialized it as 5. We happened to initialize it as a constant, so it could never change, but it also did not change, right? Couldn't have changed anyways, but that's beside the point. Okay, so then on line 10, what is going to happen on line 10 now?
It's gonna be then the line 10 isn't gonna change, so it's gonna be Eliza's favorite number, so 3 plus John's favorite number, because it hasn't changed.
So what is that?
8.
Exactly right. And then, so that's what this highlighted in blue portion does. This Eliza's favorite number plus John's favorite number sums to 8. And then we console.log the 8. So that means what are we going to see over here?
We should be seeing an 8.
Exactly right. So we press this, we see an 8. Exactly right. Sounds good. Is that clear to everybody? Are there any questions on that?
Okay, clear.
Clear? Good.
So this is in real life will be the first string will be images, and the second string will be sounds, and then images plus sounds make a video, right?
No, that's not how it works. I mean, that's a cool idea. But if you take a string of images,
very, very clear, very good.
But if you take the string of images, if you take the string of images, if you take the string of images and you add the string of sounds, then when we sum those, the computer will it's called concatenation, where it takes one string and adds it to the second string. So it's not going to get videos. This does not think like humans think. It doesn't understand any of these words.
Okay.
This is like the text, because the thing is, we're writing English words, but we could also just write this, and we could also write this.
Okay.
And so when it sums together, we get that first chunk, wherever that ends, plus the second chunk. And so that, the computer is just memorizing this as like a hunk of text. What we're doing here, like intro to programming, is like ChatGPT is doing a very different thing than like it's that's not really how code works. Like ChatGPT is like an end product that actually is processed by literally millions of lines of code. Like there's literally millions of lines of code that actually have models that, my understanding of ChatGPT, I obviously don't work at OpenAI, but my understanding of how ChatGPT works is a neural network, which basically means they build these artificial structures that look a lot like neurons in our brains. They're just digital neurons, and they have literally millions, or maybe more than that, maybe billions, I don't know exactly, that work very similar to how human brain neurons work, where they communicate information to each other, and kind of at the output of all of these billions of pieces of code running together, or not pieces of code, but all these billions of little neuron models, is that they understand code in kind of like a way that regular code doesn't. But they have literally like we're writing 3 lines of code. Like ChatGPT is going to be like millions of lines of code. Like if maybe not millions, but tens of thousands, if not millions. Okay, do you guys see the functions now?
Yes.
Okay, sounds good. So, what we do here, does anybody want to take I know you guys are totally new to this, but does anybody want to take a guess at like trying to explain to me what's going on here? If you can at all. If you can't, I totally understand. Okay, so this word function is just like, how we had let and const before? Functions, it's a different kind of variable essentially. So let and const work for strings and numbers and a couple other data types. which we can talk about later. Trues and falses, for example, those are called Boolean. So true, false, that's a Boolean type. So it works for that. There's a couple others. So a function is when I say it's a hunk of code that I want to be able to run again in the future. A function is a hunk of code that I want to be able to run multiple times. So I'm declaring this as a function. So it's like let or const. Like I say, reserve a space in memory, and we're going to call it log something. Okay, we're going to call this space in memory log something. We'll come back. So paren is basically like parenthesis is a part of a function, and log me is what I call here the argument or the parameter. And what it means is it's information that we're giving to the function. So you'll see that in a minute. We'll come back to that in a minute. Then the function, the hunk of code that is reusable, that my function runs when it's called, the piece of code that runs when I activate my function, when I use my function, is between the squiggly brackets, okay? And in this case, it's console.log something. Console.log something. And we know what console.log is. It writes output over here. So log something, and then this log me is a variable, just like we had the let and const, but we pass an argument to a function. Okay, so here we're passing the argument hello John to the function. So in this instance, log me, the first function call, the first time we call the function 3 times. We call it here, here, and here. How do we call it? We use the function's name with paren. Okay, we use the function's name. There's paren. But here we're declaring it. We know that we're declaring it. We're saying this is the function by this keyword function at the beginning. Here we're calling the function. We have paren, and we call it with this hello John. The second call, we call it with hello Eliza, and the third call, we call it with this crazy string. Okay, so what happens? The function runs the first time, and I'll actually run it. The function runs the first time. This piece of code, the code between the squiggly brackets, gets run how many times? 1, 2, 3 times. It gets run first once with this as log me. So log me is this. So we console.log this. Then it gets called a second time. Log me, console.log this. We log this. And we call it a third time. Log something, console.log log me. Log me is this. So we print out this, and this prints as these 3 lines. This is a line break character. So that's what's happening here. Does that broadly make sense? Are there questions?
It's just basically kind of breaking down the definitions, because you're telling us, I mean, from what I understand, you're telling us the concept of it, which is like the example before the definition. So I want to know the definition and then apply that to the example that you're giving.
So it's funny that you're using the word definition, because we actually call this a function definition. So this is where I define, just like you define words, we define the word log something. We define the function log something. So the definition for this function is actually the stuff in the squiggly bracket. But a function, how you can think of a function, it's not quite the definition, but the practical meaning in informal language is a hunk of code that we can run multiple times. So here we have console.log log me. A better example, the reason we would do this multiple times is we could say const Joe says, okay, and then we log, sorry, that was terrible, Joe. So we have this constant Joe says, it's just a string, and I could say console.log Joe says log me. Okay, the point is, now this Joe says, we've only written it once, but it actually shows up 3 times. Why does it show up 3 times over here? Because the function is a hunk of code that we want to be able to call and reuse multiple times. So it's everything between the squiggly brackets. So we have this code, Joe says, and then we log Joe says plus whatever needs to get logged, this log me variable, which we're passing in here, or we're passing in here, or we're passing in here. And we log, and so it says log Joe says plus log me. Maybe I should change this word from log me to like, to just text. I'll just call it text. So log something with an argument of text, log this text, log this text, log this text. But in addition, in that function, we've said prepend or add at the beginning this variable Joe says. Const.log, Joe says, text, Joe says plus text, blah, blah, blah. And there you go. So that's what that is. Okay, so I do actually need to wrap up here, so I'm not going to reopen it to questions again. But a couple things I want to tell you guys really quick. So you guys already know this. First of all, thank you so much. This was a great group. I had a lot of fun. Very inquisitive. Also, please.
Thank you very much. Very good.
Good. I'm glad. I appreciate that. Come next time. So I have HTML. This is the hardest of the three I do, by the way, because this is real code. Like you're actually really, really, really doing code. The other ones are like the HTML. It's easier. It's definitely easier. This regular code, this JavaScript is about like manipulating data. HTML is about like making this font look pretty and making this background red and making this square and making this have a curved thing here, blah, blah, blah. So that's what, like font size, the structure of your page, that's all HTML. Put an image here, that's all HTML. So that's what HTML is. And then code is things that are interactive. So for example, I'll give you an example of something that's JavaScript. And it's, let's say programming. So I search for programming, our web page just changed. Like, look, our web page just changed. Here, it's your computer's processing data. It's saying, okay, filter to things that contain programming, aka if we don't have the if statement up anymore, but if title contains programming, then keep. Otherwise, don't keep. Like that's the logic here. So that's the JavaScript part, and the HTML part is like the colors and the images and blah blah blah.